All right, welcome to the video for 7.4 notes, quadratic equations in vertex form. Feel free to skip around if there's just part of the notes that you need, or you can watch the whole thing, but let's go ahead and get started. So first thing that I want to go back over is quadratic equations in standard form, which is the one that we know already. So a quadratic equation in standard form will be, or in the form of y equals ax squared plus bx plus c. So we've factored with that kind of quadratic equation. We have talked about the a value. So if a is positive, then we're concave up. If a is negative, we're concave down. We've talked about the c value, which is always the y-intercept. And then a and b together, we have talked about how negative b over 2a is equal to the x value of the vertex and therefore the axis of symmetry. Okay, so standard form tells us quite a bit about our graph. So here's the thing though. If I were to give you a graph of a quadratic function, so something like this right here. So I know that I'm concave up. So I know that my a value is positive. Let's see, I know that my c value is going to be 6 because that's my y-intercept, but do I know my a and my b for certain? Like I know that my a is positive, but how do I know if my a is like positive 1 or positive 2 or positive 2.3 or positive 4? And how do I know my b value at all? So the idea today is, since we don't know at this point in our math career how to find standard form of a quadratic function from a graph, we're going to learn another form called vertex form that we can find from a graph. And then we're going to be able to convert that into standard form. So a little bit of a multi-step thing going on here. It's just kind of like if I were to give you two ordered pairs, like 3, 2 and 1, 5, and I were to ask you to find y equals mx plus b. So we can find the slope, no problem, just y2 minus y1, x2 minus x1. But as for the b value, I didn't give you the b value, so you got to put it in point slope form and then rearrange it. Same idea today. We can't get into standard form right away, so we're going to put it into a different form and then rearrange it. So kind of long intro, but let's go ahead and actually get started. So in addition to standard form, quadratic equations can also be written in vertex form, shown below. So as you may guess, the most important thing to know for vertex form is the location of the vertex. So vertex form looks like this. I'm going to go ahead and color code here. I got y equals a times x minus h plus k. Okay, so my x and my y, as usual, are just my input and my output, but the a, h, and k are my parameters. They're my variables. They're the values that are specific to each parabola. So you might notice that the only one that is in common between vertex form and standard form is a. And that's because whatever the a is in this form, standard form, will also be the a value in vertex form. That's why we give them the same variable. So that's really nice because we know for sure that the value of a still determines concavity. So if a is positive, we're concave up still. If a is negative, we're concave down. So the a is the same. Now for the h and the k, if I had you guess what h, k is the coordinates of, what important point are we talking about today? Well, the vertex. So we get the h and the k from the ordered pair of the vertex. So h is our x value of the vertex, k is the y value of the vertex. And I know that because it goes h, k, which is always x, y. It's also really nice because h comes before k in the alphabet, x comes before y in the alphabet. So many things in math are alphabetical, and it's really nice that they work out that way. Okay, so the h is the x value of the vertex. And we see in our formula that the h will always be inside the squared quantity. So in other words, inside the parentheses that are being squared. So it's grouped with x. And I'm gonna have a third bullet point that I'm not gonna fill in yet. We'll come back to this. Okay, for the k, it is the y value of the vertex. It is outside of the squared quantity, like you can see right here. It is not part of what's being squared. Then again, I'm gonna have a third bullet point that I'm not gonna fill in yet. Okay, and let's see, for the h value, which is the x value of the vertex, we have talked about that a lot so far because we know that -1 times b over 2 times a is also the x value of the vertex, which means that this has secretly been equal to h all along. Just a little connection to make there. And then whenever we plug this back into the equation for x, the y value that we get is k. So let's see. I want us to look over here and talk a little bit more about that h and k and about that minus and plus. Okay, so if you were in front of me, I would ask you a question, and it would be this. Do you agree that that is still true? Hopefully you're saying yes. Do you agree that this is still true? Hopefully you're saying yes. And what about this? Yes. This? Yes. So I want you to ask yourself, what happens when I multiply a number, whatever my h value is, by a negative? Will the sign stay the same, or will it flip if I'm multiplying by a negative? Okay, likewise, what if I multiply a number by a positive? Will the sign stay, or will it flip? Okay, so have that kind of in the back of your mind, and let's look at these over here. So I'm going to write our formula up here, y equals a times x minus h squared plus k, where h comma k is the vertex. Okay, so I'm going to pull up Desmos. We got f of x, another word for y, f of x equals x minus 5 squared plus 2. My vertex is at 5, 2. Hopefully you can see where I'm getting that from on Desmos. Now, thinking about that minus and that plus from a second ago, what happened here? We had a quote-unquote minus 5, but our h value was actually a positive 5. The reason for that is because the negative or the minus is already part of our formula, which means that the h has to just be 5. Now, likewise, the plus is already part of our formula, so the k has to just be 2. And our a value is technically 1, meaning that we're concave up, so that this vertex is a minimum. Okay, now let's look at this r of x down here. All right, first of all, I do not see a minus this time. So this and this do not match. What that can tell me is that plus a positive 6 is the same as minus a negative 6. So my h value is really negative 6, and my k value is really plus negative 4, so it is negative 4. So coming back to right here, what happens when you multiply by a negative? The sign flips. Hopefully that's what your prediction was. And here, multiplying by a positive, the sign will stay. So here, that quote-unquote negative 5 flips to a positive 5, but that positive 2 stays positive 2. This positive 6 flips to negative 6. This negative 4 stays negative 4. Awesome. And now, this one, our a value is 3, so we're still concave up on this one as well. So this vertex is also a minimum. Okay, now here, y equals negative 4 times the quantity x minus 10 squared. Okay, remember this is going to flip to be a positive 10. And then I don't see a k, but hopefully you agree with me that I'm technically adding 0. So it's at 10, 0. And since my a value is negative 4, I'm concave down, and this is a maximum. Okay, So putting that all together, my h value will, like the sign will flip, quote unquote, and that's due to the fact that it's being subtracted, like that subtraction is part of my formula, and the k value will stay, the sign will stay, and that's due to the fact that it's being added. That addition is part of my formula, once again. Okay, so I'm gonna do a couple of drills. Feel free to pause me and then write down, or like keep track of your prediction or your answer, and then unpause me and see if we match. So if I were to give you, let's see, I'm gonna write this down, a times x minus h squared plus k, this will always flip the sign, this will always keep the sign. Okay, so a couple of examples. If I were to give you this, oops, squared plus 3. Okay, press pause, come up with what you think the vertex would be, so what you think the h comma k would be, and then when you have it, press play. Okay, here, this -2 will flip to be a +2. This +3 will stay +3. So hopefully you got that. All right, let's do a couple more. We got y equals x minus 6 squared minus 4. Okay, pause me, give me your prediction, then press play. Okay, this will flip to be a +6, and this will stay -4. Okay, 2 more. Let's try x plus 3 squared plus 7. Okay, press pause. All right, this will flip to be a -3, and this will stay a +7. And then last one, what if I gave you x plus, 9 squared minus 5. Okay, press pause. And this one will be flipped to -9, comma, -5. Okay, if you're feeling pretty good about that, then you are ready to move on. If not, shoot me an email, tell me what you're struggling with, and I can email you back like a sort of targeted video, just like to you specifically. I'm gonna cut this video off here just so that it's easy to upload to YouTube. I'll call this one part 1. I'm thinking that there's gonna probably be 3 parts total. So this is part 1. I will see you in part 2.